Okay, guys, we're going to go ahead and we're going to take a look at problem number 22. So this is the information they gave you about problem number 22 about the M&Ms, and they want to know what's the probability of one M&M selected being brown, okay? So just to note, probability of yellow, they told us was 20%. Probability of red was 20%. Probability of orange was 10. Probability of blue, I'm going to use BL for blue so I don't get it confused with brown, was 10. And probability of green was also 10. So the probability of the M&M being brown is basically going to be the probability of it not being all of those other things, okay? So it's going to be 1 minus these probabilities put together. Okay, so the probability of being brown, I'm going to use BR for brown, is 1 minus the probability of it not being brown. And remember, we show that with the little C there. Okay, so let's figure out the probability of it not being brown. Okay, the probability of it not being brown is all of these put together. So it's 0.20 plus 0.20 plus 0.10 plus 0.10 plus 0.10. Which is 0.70. Okay, so that's the probability of not brown. So the probability of brown is actually 1 minus 0.70. So it's 0.30. Okay, so that is our first answer. Our probability of brown is 0.30. Okay, let's find the probability of yellow or orange. So the probability of yellow or orange is going to be the probability of yellow plus the probability of orange, okay? So that's going to give us the probability of yellow was 20% or 0.20, and the probability of orange was 10%. So the probability of yellow or orange is going to be 30%. Okay, let's look at the probability of it not being green, okay? In order for it to not be green, okay, we'll express it like this, probability of not green with that little c, meaning not, okay? That's the probability of, it's going to be, probability of not green is 1 minus the probability of it being green, okay? So we need to take away green from the total outcomes, which is 1, right? Or the total probability. So remember, the probability of green was 10%. Okay, so the probability of not green is going to be 1 minus 10%. That's all the possible ways besides green, is going to be 90%. Okay, so that is the probability of not being green. Okay, all right, and then let's look at the probability of striped. Okay, we know that all of these things and brown add up to 1. Okay, and so there's nothing left for striped. So the probability of being striped, I'll just use STR for striped, is going to be 0 because we have all our probabilities already. They all add up to 1, and so striped is not included there. Okay, next we're going to go ahead and we're going to move on, and we're going to take a look at these ones down here in number 24. Okay, so in number 24, the first one says, we're talking about pulling 3 M&Ms in a row now, and we're using these same probabilities that they gave us in problem 22. Okay, so if we're talking about 3 M&Ms in a row, those are going to be individual events, so we can apply multiplication rule to these independent events. Okay, so the first one is, what is the probability that all are brown? Okay, so if I want to know the probability that all 3 are brown, that's going to mean I'm going to take the probability of brown and multiply it by the probability of pulling another brown, and then multiply that by the probability of pulling another brown. Okay, so I'm basically pulling 3 browns in a row, so I want to take each of those probabilities and multiply them together. So that's going to be the probability of brown, remember from what I found up here, was 0.30. times 0.30 times 0.30. Okay, so that probability is going to give me, when I multiply all of those together, it ends up being 0.027. So it's a pretty low probability. It's, about between 2 and 3%. Okay, that I pull 3 browns in a row. All right. Let's take a look at the next one, part B. Okay. This one is asking, what's the probability that the third one we pull is the first one that's red? Okay, so let's really think about what's happening here. In this one, if the third one that I pull is the first one that's a red, what's really happening? Okay, what's really happening is I'm doing, the first one is not red, and the second one is also not red, and then the third one is a red. Okay, so these are my 3 independent events, not red, and then the third one is finally red. Okay, so let's think about what is the probability of not red. Okay, not red would be 1 minus the probability that it's red. Well, the probability that it's red is 0.20. Okay, so the probability of not being red is about 80%. Okay, so let's take these, okay, and figure out what we have. We can multiply each probability of each independent event. So I'm going to get not red is 0.80 times another not red is 0.80 times red is 0.20. Okay, and so when I multiply all of those together, I get 0.128. Okay, so my probability there is about 12.8%. Okay, let's take a look at letter C. What's the probability that none are yellow? So this means that 3 times in a row I pull and none of them are yellow. Okay, so I want you to think about, remember, the probability of yellow was 20%. So the probability of not yellow is going to be 1 minus that, right? So the probability of not yellow is 80%. Okay, so the probability of none of them being yellow would be the probability of not yellow and another one still not yellow. Okay, so it's 3 not yellows in a row. Okay, so to find this probability, I'm going to go ahead and do my probability of not yellow is 0.80 times 0.80 times 0.80. Okay, so I go ahead and I multiply all of those together, and I get that probability is 0.512. Okay, so about a little over 50% probability that it's going to be not yellow for all 3 in a row. Okay, all right, let's look at this last one. The probability of at least one is green. Okay, so this is probably the most confusing one. Okay, let's think about this. I know the probability of green is 10%. I know the probability then of not green is 1 minus that, which is 90%. Okay, so what is the probability that at least one is green? Okay, when we're talking about at least one being green, what that would mean is that at least one being green is like the opposite of no greens at all, right? Okay, it's like the complement of no greens at all. So what I need to figure out is 1 minus the probability of no greens at all. Okay, move this up a little bit. Okay, so the probability of no greens at all would mean that I have to pull 3 in a row that are not green, right? And I want to find 1 minus this because that leftover is giving me what is at least 1 green. Okay, so I'm going to do 1 minus the probability of no greens, and so that's going to give me The probability of no greens would mean 3 not green in a row, right? So 3 not green in a row would be 0.90, 0.90, 0.90. Okay, so I want to multiply all these first and then subtract. So I'm going to get 1 minus, I multiply those, I get 0.729. Okay, and then once I finally subtract that, I'm getting 0.271. So that is my probability that at least one is being green. Okay, and remember, to do that, I had to take away 1 minus the probability of no greens at all, because this is like the opposite of this, right? Okay, that'll be it for today.